Okay, we're in 10-2, and it's going to be all about angles inside of circles. And we're going to say that we are going to be measuring angles and arcs. And we'll talk about what both of those mean in just a second. So first we're going to start with a circle. So this is going to be circle B. Okay, and in the center of our circle, we could have an angle that comes out from it. And you've already started a little bit of this before. So we're going to have A and C. So the first thing we want to know is what type of angle is that? What is that called? That's called a central angle. All right, then something else that we have, let's go ahead and label that. So that will be angle ABC. All right, something else that we have from A to C, right along here, we have this curved section of the circle. It's like a piece of the circumference, right? It's like the crust of a pizza, or just this little distance from A to C, but it's not a straight distance. It's along the circumference of the circle. So it's this little curve, and that's called an arc. Okay, so this is an arc. Now, this arc specifically is called a minor arc. Okay, a minor arc, and you'll see in a minute what a minor arc is and what a major arc is. And the way we say it is that this is arc AC. So we put an AC, and instead of a segment, we put a little arc or a little curve over the top of it. And something that's interesting about these arcs is that the measure of arc AC, which means the degree measurement, anytime you see the little m, it's the degrees, is equal to the measure of angle ABC. That may not seem very exciting right now, but in a minute it'll make a lot more sense. So now we're going to go back over to our picture, and I said that this was a minor arc. Well, there's also a major arc. And so a major arc goes from the same points, just like this, all the way around, but it's going the opposite direction. And the direction is not as important as to how it got from A to C. Now, if we want to name it our major arc, okay, we don't call it AC. What we need is a third point. So over here on this side, there would have to be some other point. So this would be point D. So the major arc is arc ADC. And we label it and name it by where it starts, what it goes through, and where it ends. Okay, so the minor arc and the major arc together make up the whole circumference of the circle, and they add up to 360 degrees, which makes this pretty easy to find the measure of our major arc, ADC, which just equal to 360 minus the measure of angle ABC. Okay, and so effectively what we're finding, you don't need to draw this on your picture, but just look, is this was angle ABC. This is the angle that we're going to find with our major arc. So don't get too caught up in the picture or worrying about it too much. I promise it's very easy. So do another circle. And in this circle, I'm going to put some segments and make a couple of angles. So we're going to have one segment that goes to our center, another segment that goes to the side, and then this segment that goes down the side. So this is random. There's no structure to this, or don't worry if it's not the right size. Try to get it going to the center or something like that. What we're creating here is three angles. So we have A, B, C. And we split this circle up into angle 1, angle 2, and angle 3. Right? So we already know from above, right up above here, that angle 1 and arc AB are equal to each other. And we already know that angle 2 and arc BC are equal, and angle 3 and arc AC are equal. Well, something you already know is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360 degrees, because you know that inside a circle, all the angles add up to 360, right? Well, an arc is the same way. So the measure of AB plus the measure of BC, this is arc AB and arc BC, plus the measure of arc AC, you could have said CA, so those aren't very good arcs, but you get the idea. You could say AC or CA, it doesn't matter. Those add up to 360 degrees. So what we're saying is AB plus BC plus CA or AC equals 360 degrees. So that's not some kind of rocket science revolutionary thinking that nobody's ever seen. It makes sense, right? So we're going to write down something called the arc addition postulate. So arc addition postulate. And we're going to make a circle. Here's our circle. We're going to put a center in it. So center C. And we're going to put 1, 2, D. And so what we're going to say here is that the measure of arc AB plus the measure of arc BD equals 2. And think about what do you think we're going to say here? Okay, so if we took AB plus BD, that's going to equal the measure of ABD. Okay, and it's okay to name the points that it goes to like that. So ABD. You could just say AD, but all we're saying is that this arc plus this arc equals the bigger arc. And hopefully you remember something called a segment addition postulate. If we remember that, or we had an angle addition postulate, but all it said was if you have a segment, that this part plus this part equals the whole thing. So nothing different, nothing new, just a different way to see it, but it's still the same idea. Okay, something new that you haven't heard before, but I promise is easy, and I promise you've already done it without knowing, is something called arc length. Now, very important to note, arc length is not the same as arc measure. Okay, arc length right here is a distance, a length, right? It's how far something is. So a couple little notes. Arc measure, which we've already done, is in degrees. Okay, so quick example. Draw a terrible little circle here. And we say that this is 60 degrees. This is A. This is B. Well, then the measure of arc AB equals 60 degrees. Okay, fair enough, right? Everybody's okay with that. So arc length is in linear units. That's inches, feet, centimeters, miles, etc. Right? It's a length. It's how long it is. Okay, arc length is a portion of the circumference. We'll do one example. We're going to be finished. So example, we're going to draw the same circle. We're going to say this is 60 degrees. And we're going to have, this will be point A, point C, point B. And the only difference between the pictures is we're going to know that this radius is 5 centimeters. So if we want to find the arc length, well, that is equal to the circumference, 2 pi r, times whatever the measure of the central angle is, divided by 360 degrees. So hopefully that looks familiar, and you say, oh, you're right, we have done this. So arc length for this circle is 2 pi times 5 times 60 over 360, and that's equal to 10 pi times 1 over 6, which is equal to 10 pi over 6, which is equal to 5 pi over 3 inches, or centimeters, sorry. So this is the answer. This is what we want to put on our test. So as we move forward now for these next little finishing up the year, let's start to leave all our answers like this. Now, that's approximately 5.24 centimeters. So if you were going to Home Depot and you needed to buy something, don't go buy 5 pi thirds. They're not going to be able to help you. Go buy 5.24 centimeters and they'll get what you need. But in our math class, and for all you future engineers, computer programmers, architects, all that fancy math stuff, you got to start leaving your answers like this. So that's it. See you tomorrow.